And we're live. Welcome to Seller Sessions. I am your host today, Sharon Evan, and today I have with me the amazing Amy Weiss from Amazing at Home, Barcus, Patty, and Nick. Is it Barcus, Patty? Is that how you pronounce your name, Barcus?
Yeah, you got it right.
And Nick, is it Nick relation? I've never had to say your full name out loud.
It is Nick relation. Yep. That's what the IRS knows me as.
Well, that's what we'll call you.
I just want to say that Barcus and Nick have way cooler names than us.
Nah, Amy, your name is super cool. Don't ever down, but your name's awesome. And my name, just so you know, my real name is Evan Chen in Hebrew, which is actually a stone. So my name is technically Sharon Stone. So, nice. You know.
That's makes me think of like the Avengers or something. I love it.
Yeah. So I wanted to, today we're going to be speaking about 3D printing, and I wanted to sort of give a bit of context to why I thought that this would be an awesome subject. I know that I'm looking to the right for those that are watching us live. It's because I'm trying to make sure that I can see us live. And the reason that I wanted us to speak about this is because there isn't enough awareness about the fact that you can 3D print your own products. There's many different things. Amy will also share what she did. She even built a 3D printer. But I wanted us to speak about this because I don't think it's for everyone, okay? But I do think that it's many people it'll make sense for them. So a little bit of a backstory actually starts with Nick, who is here. So Nick and Jolita are clients of mine who came to me with their product idea. And I said that it's something that you definitely need to try. I believed in the product. I didn't know that they were going to 3D print it, but what they did for proof of concept, because the mold was very expensive because they literally designed it themselves, instead of going and spending, how much money was it on a mold, Nick?
In China, through a contact, $15,000. We tried to look at some manufacturers in the States, and it was upwards of $50,000 US.
So
right.
Yeah. So instead of going and spending on a mold so much money, Nick and his beautiful wife, Jolita, went and they bought a 3D printer and they started to 3D print their product and sell it on Amazon, handmade, for proof of concept. And when Nick had told me about this, I had then gone and told a few other people that are clients of mine. And I was like, hey, look, and before you go and spend 12, 15K on a mold, why don't you try the 3D printing route? So that's what some of the people did. And it's just crazy because yes, Nick is an engineer. He's going to say who he is in a minute. And yes, someone else in the group called Stuart is a CAD technician, but two other people are just your regular, average Joes that are not. And I think that some of us here are as well. So that is a little bit of context for why I wanted us to speak about this, because I know you guys all here have done either something similar or even used a 3D printing in order to make a mold. So that's a little bit of context for why I wanted us to talk about this. And before I start with some questions and for each of us to tell our story, maybe we can do a 1-minute intro for who we are, starting with the one and only Amy Weiss from Amazing at Home. Amy, for those there's like no one who doesn't know you, but just in case someone doesn't, you want to give a brief intro of who you are?
Thank you, Sharon. Well, I'm Amy Weiss from Amazing at Home. We help entrepreneurs actually develop unique and differentiated products and take them from concept all the way to launch. I'm in Texas right now, and we are in the middle of a crazy winter storm. So you guys, if you've seen me before, normally I'm in my Amazing at Home office, but today I'm in a theater room at a friend's house who happens to have power, water, and all internet, the nice things in life that we haven't had in our house for the last few days. So I'm just happy to be here. Thanks for having me today. I look forward to nerding out over all things 3D printing and prototyping.
Amy, you forgot to say that you're also an inventor. You've actually invented your own product, which is also a key thing for today's conversation. So you actually invented your own product, and we'll talk about that very shortly. That's amazing. Barcus, Who are you, Barcus? You're on mute. There you go. Oh, no. Yep. Cool.
Barcus Patty. I work for Helium 10, and I've been in the Amazon space and also the Amazon software space for about 6 years. Sold various products on various marketplaces with various degrees of success. And yeah, I just gotten into 3D printing for several reasons. We'll talk about them later. So, but thank you for having me. I enjoy the nerd out sessions just as much as Amy does. So
that's awesome. We're happy to have you here. Thank you for being here. And Nick, who are you? For those who don't know.
Thanks, Sharon. Super excited to be here with you folks today. I'm a cloud engineer. I'm located in New England here in the States. My wife and I sell a handful of products on Amazon right now. And we really got into 3D printing to really, for me, it was something fun because I'm an engineer. It was something interesting. I like making stuff, but also to really test our product to figure out, is this something that's viable? Are we going to have any defects if we actually make a mold of this product? And then also for just prototyping things that I'm working on and to print stuff just to fix things around the house too. I've done that more than a few times.
Nick, because you're an engineer, this specific question will be for you, but how complicated do you think 3D printing is for normal people who aren't engineers or CAD technicians?
I think
not that you're not normal. I mean, people who aren't.
No, I gotcha. I think it's like any hobby. It can be as complicated as you want it to be. You can buy pre-made, pre-assembled 3D printers that are pretty much just take it out of the box, press a couple of buttons, and you're good to go. The 3D printers that we have are a little bit on, I think, the higher end. They require a little bit more maintenance, a little bit more tweaking, some assembly. But it's nothing that, doing some Googling, asking in Facebook groups, or just asking a buddy, might be able to help you with it as well.
Cool. That's awesome. So I want to take it back to Amy, and then we'll sort of do a round table. We'll go around and all speak about our experience with 3D printing. So Amy, you invented a product. Can you tell us a little bit about your history with 3D printing?
Well, when I started inventing my product, and now I've got 2 under my belt, and when I started, I had this concept, right? I started with drawings, and this is kind of what anybody who has an idea and wants to get it from concept to launch, when you first start, you kind of want to draw your concept to make sure that it works, not just in your mind, but that, you can imagine how it might work, the steps to using it, the shape it would need to be. So the easiest thing to do is start on paper with sketching, right? And that's what I did. I started on paper, sketching it out, and said, okay, how would this actually work? It seems like it works in my head, right? And then after I did that, I went and built a prototype. And so you don't always have to 3D print. I think some of the best thing that you can do, and this is what I recommend for anybody that's in our program when we're developing a product, is start by prototyping it on your own. So, for example, my husband and I were building a gym bag specifically for weightlifters. And I mean, I can sew a little bit, but I wasn't going to sew the bag. I wanted to know, okay, we want shoes over here. We want wet clothes over here. So we just took poster board and some tape, and we laid it out on the floor, and we figured out, okay, this needs to be this big, this needs to be this wide. Oh, that zipper is not going to work there, right? Anything that you can do. Oftentimes people get very overwhelmed because they're like, okay, but I can't build something. So that's what I did. After I did my drawings, I went to Home Depot and I found some hardware mesh and some wood, excuse me. And I got a few things and I brought it home and I put this prototype together. And it was ugly, and it was definitely not anything that you could use on the market, right? But it worked. And it also, it reminded me, it made it so easy to clean the litter box, which was the problem that I was trying to solve. And so it worked really well. But from that prototype that I built myself, I was able to get feedback from friends. Right. So my friends were, told me, and I had them sign an NDA because I was so afraid back then. I had no idea that 99% of people would never, steal your idea, but because they have no idea how to bring a product to market. Right. Just like I didn't have any idea at the time. And so I took that prototype and I got feedback from friends. And so from there, I knew how deep my product needed to be. I knew how wide it needed to be. Now I'm not an engineer. I'm a smart girl, but I'm not an engineer. And so getting that feedback from friends, so I call this DIY prototyping. You build your own, so let's say you have a product you want to make out of plastic, right? Or metal. Well, build it out of wood first because that's easy. You can shape wood, you can turn wood. I'm sure you can find, if you look for maker spaces near me on Google, you will find places you can go and get a CNC machine, utilize 3D printers, anything that you can imagine. Here in San Antonio, we have a lot of these types of spaces and resources. So anyway, you take it from that. I had that, and then I got the feedback from friends, and I realized, okay, and not just friends, because you don't want to get feedback from your mom or your friends, right? But these were friends that specifically were in my demographic. Like one of my ladies, one of my friends, she did foster cats, all this kind of stuff, right? So I knew her feedback was going to be stern and valuable. So get the feedback, figure out what I needed, and then I sat down with a friend who could do 3D CAD. Now, this is another thing. You can hire somebody who does 3D CAD on Upwork, anything like that. But if you can, find a 3D CAD engineer that's near you, because it's so great to be able to sit down and actually kind of design it together. So I actually had a friend at work. I worked in a building full of engineers, and I had a friend at work that his name's Dallas, and he was like, Amy, that drawing that you have looks like a jockstrap. And he's like, I can help you turn that into something better, So we sat down together, and so here we had this my product's large, right? It's 14 inches on one side, 14.5 on another side, and 7 inches deep. Most 3D printers are very small, the other thing you can do with 3D printing is you can print a mini version of it.
Yeah.
So if you have a really large product, you can scale it down, and at least then you can get the feel for it. So we actually made one that was Barbie sized in the beginning, and my daughters played with it for a long time with their Barbies. But so that's another option. But we had a smaller 3D printer, and we had to break the product up into pieces that could be 3D printed and then snapped together. And we used a lot of pieces and snaps and glue and anything that we could just to get this thing so that we could hold it in our hand. And we took this to manufacturers then. Here locally in San Antonio and the surrounding area, we took it to manufacturers, and we actually had manufacturers say, hey, do you have a business card? And we were like, no, we don't do this. This isn't like our thing, And he's like, well, people don't bring me prototypes like this, right? So if you can, the 3D printing, instead, a lot of people, what they do is they take that prototype and they go straight to the manufacturing stage.
Right.
This is incredibly actually dangerous because that mold that Nick was going to pay $15,000 to $60,000 for, I paid $42,000 for my mold.
Wow.
I used a US-based liaison, so of course it was much more expensive than I would have paid had I gone straight to China. But I didn't have a China trip yet at that point, right? So it was well worth it because I validated the product before I moved to market, because I was able to take that 3D printed prototype and do a fundraising campaign. I was able to get feedback because when people can visualize something, then they can give you good feedback on it. So I didn't sell the 3D printed model on the market. It would have been way too expensive for me because plastic, you have to buy the plastic for 3D printing, and that's kind of expensive. So anyway, that's kind of a background on 3D printing. What you want to do is, if you can get your prototype as close as possible to the way that you want it manufactured, Then what you're going to want to do is make sure that, so you're going to make sure that it works. That's what's great about 3D printing. You can 3D print something and you can make sure that it actually works. If it's not plastic and you can't 3D print it, you can 3D print with many different materials. But if you can't 3D print it, there are different types of mechanisms. Like I had invented another product. I haven't brought it to market yet, so I can't talk about it.
Don't say what it is. Yeah.
But we ended up actually carving it out of some fiberglass type material because we had to, the 3D printing, we tried 3D printing, it would just snap. We needed something that held tension. So anyway, yes, I'm a serial inventor. I'm always coming up with new ideas. And what I love about 3D printing is you can take your idea and actually help it come to life without having to pay for a mold yet and all of that. But everyone, the one tip that I have for you, if you get it to 3D printing and you're like, yes, this is awesome. It's so usable. This is really, and you're able to validate the product using that 3D printed model. What I would really, really suggest for you, and just make sure that before you go to a manufacturer in China or anything like that, that you actually have a DFM, a design, you have that design, that 3D CAD actually done by someone who is certified in design for manufacturing. Because just a 3D printed prototype or 3D CAD is not the same as a product that needs to work in practice and a mold that needs to be made. And often if you move straight into mold making, if you, for example, find a manufacturer in China, they're going to give you exactly what you ask for.
Yeah.
So if you give them, and I see Nick's like shaking his head, he's like, "Yep, that's exactly right." But so you want to make sure that you have that design checked by a design for manufacturer. So I started with a 3D CAD artist, and we got there, but then we actually went to a DFM so that we could make sure that in practice for actually this product in the long run, that it would work. So that's just a little background on 3D printing, and we actually did build our own 3D printer. I can't take credit for it. I mean, Dallas did that, but I was very involved in the process, and I was so excited because all the possibilities. But yeah, it's there's so much you can do with it, and I love it.
The thing that I love about the panel here is that each one of you guys have done something different with the 3D printing. So for you, for this specific, what you just told us was for not necessarily just a proof of concept, but you actually like 3D printed your product in order to use it, check it, make changes to it as well before you went straight to actually getting your mold done, etc. So that's super, super cool. Barcus, you're playing around with 3D printing right now. Can you tell us a little bit about what you're doing right now with 3D printing?
Yeah, playing is a very accurate term.
That's why I chose it.
Yeah.
I see you're doing different things.
So, I got into it about a month ago. So a friend of mine had a 3D printing business with some investors, and they just parted ways. Everything was amicable, but they left, and they dissolved everything, but they left him with all the equipment. And we were sitting there talking one night, and he's like, "Man, I got an extra 3D printer. If you just pay for shipping, can I send it to you?" And I was like, "Well, of course." So that's how I got into it. And we started talking about his stuff, and he kind of ramped me up. But I got my idea currently right now that will probably change before this call ends is to manufacture things at mass to sell on Amazon. So I've got a market. I've done the product research, market research. I know what I can and cannot print. So now it's getting the right material just for durability and strength. And then how I don't want to get into a product right now that I can't scale. So there's a couple, I've got them broken down in a couple different categories of these are that I could print and scale and meet the demand. And then this is, I need to buy more printers to meet the demand of that. So, but it's also possible that I might just refine this over a couple of months. And then if it scale it to a certain extent, then just send those files to China and then get those manufactured. Yeah. So it's, I don't know, who knows what I'm going to do, honestly. So
you're using it currently would you say then it's for like proof of concept right now, or you're just playing around with different products, trying different things? Because you're going to sell, which is different from what Amy was using that to make her you know, the concept side of it, but you didn't sell it, Amy, right? You didn't actually sell you said your prototypes. So Barcus,
yeah.
Yeah.
And the cool thing too also about 3D, when you have it in 3D CAD, you can actually use that to create concept videos too. So that's what we did. We created videos and images so that, you know, we could validate it. Because how do you ask customers, hey, what do you think about this? And how much would you pay for it? And would you buy this? You can't ask that if you don't have like a decent mock-up. And of course, you don't have to 3D print it to do that. You can have somebody who's really good at Photoshop do that for you.
Of course.
And, you know,
yeah, of course. So Barcus, you're doing the opposite, where you're actually going to sell what you're printing.
Yes.
Right?
As long as I can get the strength down. So there's and Nick is probably can talk more about this, but there's certain software that you can build something in 3D, like in CAD, and then you can look at like the stress points, like can this break under a certain kind of pressure and that kind of stuff. So that's what I'm learning right now is that it's Fusion 360. There's a free personal account that you can get with them. So I'm learning that for just learning CAD, so I can actually design what I really want to design. But then, like I said, like the products that I'm going to make, they need to be durable to a certain degree. So I'm trying to figure out what's the best material for that I can actually print well, and then you know, again, like just the file, it's like the strength of it. Like I don't want it to break under pressure, for example.
So let's just say you've 3D printed it, and it's not breaking, it's working. You're going to package it, send it. You're going to sell it on Amazon or Etsy, or what are you going to do?
I'll just start
or
on
both?
Amazon. I'll start on Amazon first. Like I am the king of trying to do a million things at one time. So I'm trying to focus on selling these 2 or 3 items, ship them to Amazon, and build revenue, go from there. So.
And then if it works, we've got proof of concept that works, you start getting too many orders that you can't handle, then you'll say, okay, it worked, and probably move to China, right? Probably.
Maybe. So the easiest thing to do would just to be buy more printers, and then scale that up, because with certain hardware and software upgrades, you can ultimately just automate the entire production line. And then, you know, as long as you still have power and internet, then you should be fine. So,
and for those people that don't have a 3D printing farm like Barcus, you can use something like angled.io that allows you to create a 3D product and print it on demand. So they have 3D printing farms that work with them. And so if you just wanted to throw a product on the market to check it out, but you don't have access to your own 3D printer or to a friend that has an amazing 3D printing business, you can use these new platforms where they're allowing people to basically put products out there. And so, yeah, check that out. It's Angled, ANGLED.io. And you'll see it's like a whole online 3D printing marketplace, kind of like, you know, Amazon, but print on demand for 3D printing.
Yeah. So another thing to point out really quickly is like the products that I want to manufacture are somewhat small. They're handheld. Like they're not massive.
Yeah.
So
like this owl.
So cost-wise, yeah, perfectly. Like to print, you know, like the cost to print that thing is pennies. Like, so the printer I have is an Ender 3 Pro. It's considered a very kind of standard of beginner printers, but you can expand and upgrade it a lot, and it does very well for its cost. I think they're like $300 on Amazon. So it's not a lot to get invested, but a lot of these things to print are like less than $1 in just the filament. So, and the products that I want to sell are $20 to $30. That's the average market on Amazon. So as long as I can get the strength and durability in there, fit and finish, you know, if I can, you know, work out all those obstacles, it could be very profitable for me. So that's a big reason I can small batch something and make a large amount of profit. Almost. We'll see.
And if your product is something small, like what Barcus is doing, a lot of libraries, at least in the States, have 3D printers now that, you know, the first 30 minutes or the first X amount of grams of filament is just free because there's grant money out there. So that allows you to really easily and cheaply at least get a couple prototypes to be like, this is what it looks like in my hand.
Yeah.
Nick, I started with Amy and Barcus because you're about to talk a lot. So I just have one more question for Barcus. I've got a lot of questions here that you're probably going to have most of the answers for. Barcus, for the people who, and obviously Nick's doing the same thing, but for the people who can't imagine or don't understand the concept of the fact that, so you've 3D printed the product and now how do we get it to Amazon? So let's just say if you want to package the product, you can always go and get your own, buy whether it's a box or an envelope type of packaging or different types of packaging, get your own labels, right? As in make your own branded labels, stick it on the product and send it over to Amazon. How are you doing it right now? Or how do you plan to do it? Because you haven't done it yet.
Yeah, that just what we call FBA. I'm just going to package up like 30 or 40 at a time and ship them off to Amazon and continue printing. So printing is pretty slow unless you have a very expensive printer. I wish I could print Bitcoin. That would be amazing.
For those that listening to the podcast,
we've got money, right?
Yeah.
We've got near reverse here.
A print farm and a Bitcoin farm or mining farm. Anyway, so yeah, just ship them off. So it takes a while. So like a cell phone case, if I wanted to, like this is made out of leather, but if I wanted to manufacture this case to make something good quality, might take an hour and a half or 2 hours to manufacture one. So, realistically, like even if you had it running 24/7, and I mean, like that's not even realistic because there's just downtime. But I mean, it's not like I can make 10,000 a month with one printer. Yeah. So time is an issue. So that's why I don't want to get into something that that blows up and then I run out of inventory and I can't even meet demand. So
yeah, I have another client. Nick, he's in our group, Johnny, and he also had something very similar, which is he's going to sell certain types of figurines. Okay, so they're the size of something like this, right? If we compare this to my thumb, so I understand, they're small figurines, and he wants to sell them in like a pack of 30. And we got from China, we got some quotes for the mold. And they can fit 5 on each one. Anyway, it was going to cost around $12K to get a mold. So I said to him, hey, look, Nick's doing this whole 3D printing thing. Reach out to him, get some information, go to YouTube because there's so much information on YouTube. Buy a 3D printer and just try it first because no one says that the exact types of figurines that you want to sell are going to work. Like, let's get some feedback from people here. And he put his listing up on Etsy. This is in regards to what you just said, Barcus. And he started getting sales from day one with no advertising. And then his 3D printer broke. And he couldn't fulfill his orders that people had just, he told me that he got his printer from Amazon. So he was waiting. I think that Nick will probably start talking about the different types of printers shortly when I get to those questions. But I think his printers, I think maybe, could it be resin, Nick? Is that what, I don't know if...
I'm not familiar with this product, but I think he's probably not doing resin.
I think he said he's doing the opposite of you, and I can't remember what he said in the group. I'll have a look soon. But anyway, he's not going to go that route anymore. But it was in regards to what Barcus said, that you start getting orders and then you can't fulfill them. Or if the 3D printers break down and you can't print. So yeah, it's hopefully it won't happen to you, Barcus. That was me just telling a little bit
plenty of times to
I'm
us.
sure it will happen.
So yeah, Nick, can you tell us about your journey to the 3D printing? Although I did say a little bit of it in the beginning. How did your product start selling from day one? Did it start selling or not on Amazon?
So the product that we sell right now on Amazon Handmade, we actually have 2 that my wife kind of came up with the concept, and then we slowly refined it into a product that we could print ourselves using the print farm that we have at our place. And during the journey, one of my fears or nightmares was, I send these files off to China to create a mold and there's a defect. Something that gets overlooked in the process of designing it. And we ran into about 2 or 3 of those, so it's much better to wait 10, 12, 15 hours for something to print at home and be like, wow, this doesn't work at all. And,
Nick, I'm going to stop you For 1 second, can you? I'm just thinking about the fact that we've got the podcast people that are going to hear. Can you take the mic a little bit away from your? We've got some feedback there. Other side, yeah, a little bit away. Thank you, because it keeps hitting your neck. Okay. Sorry, continue. My apologies. Continue.
No worries. So it's much better to try to conceptualize it at home, and then you can tweak the model as needed. And we had to do that more than a couple of times.
And how did your proof of concept go? Did you,
Yeah, so
I know that you were selling, but tell everyone else.
Yeah, so, we started printing these, shortly or about a month before Christmas, and we were selling, I think at the most, it was about 10 a day that we were selling with no PPC, no real advertising at all. And,
and not the best listing in the world either, if we're honest.
That's my wife's portion.
Yeah.
And, it was actually, when I say, we were running the printers 24/7, I was getting up at 2:00 in the morning, 4:00 in the morning to, restart print jobs and, running to the post office to mail them. And it was, at the height of it, it was like, wow, these things are literally printing money, because once you have it dialed in, the settings dialed in, it's really not that expensive.
So we have a question here from David saying, what sort of space does one need for a 3D printer? Is ventilation an issue, a solid level of surface? So important questions. Nick, we'll go to you first.
Definitely need a solid level surface for sure. Depending on the type of filament you're using, if you're printing, say, ABS or, with essentially plastic, yes, that should be ventilated somehow and should be in a somewhat heated enclosure. The most popular is PLA, which is safe. You can print that, in your office, your house. Space, I have the printers on IKEA end tables. Essentially, you don't need a ton of space.
Cool. And would you say that some 3D printing it's dangerous? Fumes wise?
If you're printing ABS, you don't want to be inhaling the fumes. It needs to be in a heated enclosure just because of the way that the material is printed and for adhesion to the build surface. But, what we're using PLA for the most part for printing our products, and it's fine. It's not hazardous to humans to breathe in.
I have my own set of questions here, but we've got so many questions here, so I'm going to choose some and bring them up. There's just a lot. So David also asked, are there any power supply requirements, 15 amp, 11 volts, okay, for out-of-the-box printers?
You could probably pretty easily run probably almost 5 printers on a standard circuit, depending on how big they are. When they're running and the bed is being heated and the extruder is on, you're probably looking at about 300 watts for draw. So, which isn't a ton. That's a computer and a couple monitors.
We've got Stuart here, who, I don't know if you guys remember at the beginning, I said I've got 4 people from my group currently, Nick, Johnny, Joel, and Stuart, who are all currently doing 3D printing for either proof of concept or similar things like Amy's had done or is also doing. So Stuart's also saying that his product idea is pretty small, so I can get quite a large batch out of a spool of filament. There's many people that don't know what you guys are talking about, so we'll get into that in a second. I'm just looking at what other questions were here.
I want to ask Nick a question real quick. Is that okay?
Go for it. Yeah.
So Nick, how many printers do you have right now at your house? And have you tried to measure like the power? Like how much extra is it per month? Or have you even looked at that? I know I'm curious, but I'm sure.
To be honest with you, I haven't looked at the power usage at all. Right now, we run about 2 printers pretty much continuously, but we've had up to 5 running continuously before. And, we don't have any sort of special power coming into.
I mean, if you think about it, it's probably not much more than a medium-sized appliance.
Yep.
Right? I mean, depending on But yeah, I've seen one of our design friends has a 3D printing business as well, and he helped me a lot with switching my stuff over to DFM. But yeah, he had several offices with printers along every wall, and no complaints of insane electricity or anything. But I wanted to throw something out there. There's this thought that you can either 3D print and try it out and get, sell it if you can print it fairly cheaply, which I think is awesome. And for those of you wondering, filament is just the material that is printed out in 3D. And that can either be ABS, which is a type of plastic, PLA, which is another type of plastic, I believe. But for those people that aren't familiar with the terminology that we're using, and basically the way 3D printing works is it prints your thing, whatever it is that you're printing, in layers. So it goes around, and if you can imagine kind of like using Legos to build a castle, right? And you're slowly kind of piling on those layers of those Legos going up, right? Or to the side. That's what a 3D printer does. And so wherever support is needed in the structure, it will print a support as well. So when you're done printing it, sometimes with certain products, you have a lot of what's called, I think it's flash, that you actually have to peel off before you'd be able to ship that product out. But it's really quite fascinating how 3D printers work, and the way that you'll want to put your print on ours, we did it upside down, because had we tried to print it this way, it wouldn't have worked. It was round on the bottom. So we had to print it so that the layers are, so there's a lot of different kind of design ideas, but I wanted to throw something out there. So you can print your own thing, right? Like Barcus is doing, like Nick is doing, which I think is so incredible, by the way, you guys. That's awesome. You can get someone else to print it, which I shared that angle.io. There's lots of 3D print marketplaces. And then as Nick mentioned, you can go to the library, you can go to maker spaces near you. There's all kinds of, you can go to universities. They have 3D printers, and they'll even help you get your stuff designed, all that kind of stuff. So there's lots of those kind of resources. But the other thing that many people are not aware of is there is rapid manufacturing in the US. So if you're already selling it and you're printing a ton of them, and you're like, okay, I do not want to build a 3D printer farm in my house, and I don't want to hire someone else to 3D print these, but I'm not ready to go to China yet, right? Or I'm not, and we just assume that it's China. Like, it doesn't have to be China. Wherever you're getting it manufactured, you're not ready to do that yet. That's okay. There's rapid manufacturing in the US that will make molds out of different materials, such as aluminum, for example, which is a much cheaper metal, and which is it's not going to make as many products, but you could manufacture pretty quickly. You could get it to market pretty quickly, and it's not going to last a lifetime like a mold made out of steel would, but it's going to get you through your first batch of 10,000, 20,000, 30,000 products. And you can make an aluminum mold for, I think it's depending on the size of the product. You can't make an aluminum mold for really, really large products, but for smaller products, it's really, really easy, and it's really, really cost effective, and you can really get that manufactured quality from your product, because 3D printing, you're going to get a quality product, but it's going to require some extra work on your part. You really are going to have to make sure that, if you guys have any edges on your product, you have to kind of clean it up. It's more manual labor than mass manufacturing would be. So there is a company called Proto Labs, and this is exactly what they specialize in rapid manufacturing, in taking your product, and they'll even take your design and check it for DFM. And so they can create now, let's say you got a product like Nick does that's selling like crazy, man. He's running 3D printers. Like, Nick, if you want to sleep one of these days, you could check out Proto Labs, and see if you can't get an aluminum mold for a couple $1,000s and pump out 10,000, 20,000 and really up it. And then you got the money, more than enough money. If it's still the life cycle on this product is still good, then you can invest in a more expensive mold, or you can buy another mold out of a cheaper metal. So I'll include the link to that in the comments for you guys. I wanted to throw that out there because I think a lot of people just assume like, okay, I either 3D print it or I have to pay all this money for a lifetime mold.
Yeah, no, that's amazing information. Also, these are the times where I wish I lived in America, right? For the people that don't live in America, and I just wanted to also say, because this is sort of going to be new to a lot of people. You all live in America and sell in America, not only but in America. Stuart, who had said something earlier, he's in the UK, and he's basically his product that he's working on is like I think you call it in English a gag product. It's like funny types of products. So he's working on like a gag product, which there is actually a lot of search volume for, and no one's actually, doing it. So he's actually printing a couple of, I think maybe 100 maximum, obviously because of the restrictions, 200 units, and he's got his own PP bag, OPP bags, put his own label on top of it with his branding, etc. Put the FNSKU on it, and he's sending it over to America. And if it goes well, and then and the other thing of why he started it this way rather than going straight to China, not only was it to have proof of concept, but also doing something while Chinese New Year, right? By the time that he would have had the product, the mold, everything, the samples, everything ready, it would have taken months coming out of Chinese New Year right now. It would have taken at least 2 to 3 months minimum.
Not to mention like trends right now. So like if he's going after we think about like the Bernie Madoff thing, like where he was sitting in the chair with the mask and the mittens, like to take advantage of something like that, like super rapid, and then the life cycle on something like that's going to be a lot shorter too, right? So
yeah,
that's amazing. That's awesome.
His product, I don't think it's too much, to be honest. It's not like I wouldn't say that it's like a trend or something, although what you're saying is totally right, because taking advantage of something right now rather than waiting. But anyway, he's almost finished. He first told me this idea, I think it was less than 2 weeks ago. I shared it in the group, Nick. It was like less than 2 weeks ago. He's already printed I don't know, at least 20, 30 units of it. It's almost ready, and he's going to send it over to he's here, Stuart, if you want to write anything, I'll put it up on the screen. But anyway, I just wanted to put that out there as well. There's some more questions, and I've also got some questions. So let me just see what I wrote down. Okay, this is anyone that wants to chip in on this, but probably Nick can give it a little bit of without getting too much into it, Nick, because it's a subject you can go on forever on. What does somebody need in order to get started? Okay, so we obviously need the printer, the softwares, etc. I made a little bit of a list, and you can go into it. I wrote obviously a 3D printer, a CAD, slicer. I learned about what a slicer is, filament, and then the rest you get into it and give us. So someone now is looking, they've got an idea, they want to, do some proof of concept, etc., whatever it may be. Maybe do what Amy did was, to print it, find what she needs to improve on it, etc. What do they need?
You pretty much listed it all.
Yeah.
Can you tell people what a CAD and a slicer is? Because I had to watch 5 YouTube videos to understand.
So CAD is a tool, something like SolidWorks, Fusion 360, or Fusion 3D, and another very, very easy and free one to use is called Tinkercad, which is web-based, runs in your browser, super easy to use. That's what's actually
it's even child friendly. It's even made. I heard for kids to do. Sorry.
Yeah, so that's what you would actually make the model in, and that would generate a file that you can then import into your slicing software, which is actually going to slice that software into little layers that your 3D printer can then understand and print. And that's where you would also adjust settings for how quickly you want it to print, if it needs support, if you need to add, more infill. Really, that's the secret sauce as to a good object that comes off of a 3D printer or kind of a poor one, how good you slice it.
And then filament, Amy spoke a little bit about. Because I also spoke about this in our group, but I watched a lot of YouTube videos, and I didn't know that you can 3D print like out of wood material. There's so much. Did you know? Did you guys know this? Amy, did you know? I didn't know that wood. How can you 3D print wood? So can you talk a little bit about the different filaments or different materials that people can print?
Yeah, there's everything from, your traditional PLA and ABS, which is essentially just plastic. There's flexible ones that, Barcus had mentioned, like you can print a flexible material that's kind of like a jelly almost that you can make like a phone case out of, or something that you can crush, and it kind of comes back to shape. There's ones that have certain fibers in it to make a filament that's really, really strong. If you're printing something that's going to be exposed to the sun, you would probably want something more like ABS where it won't warp like PLA will. And then there's tons of exotic filaments out there that, different colors, some that are glow in the dark, which is pretty cool.
Yeah. Oh, that also glow in the dark.
Yeah, there's some that are geared more towards strength, flexibility. Really, the sky is the limit in terms of filament, and it's really not that expensive either.
And then for people starting out, what types of 3D printers would you mostly recommend?
I personally only recommend 3D printers that use a direct drive technology. That's where it's really everything is mounted where the extruder in the drive motor is. And that's where you can use more exotic filaments, things that are more flexible. It's less prone to having to push the material through a tube like the printer that Barcus mentioned is a Bowden style where it has to push the filament through a long tube to get to the extruder. Either one is going to work for someone starting out. I personally only recommend direct drives, and that's the only ones that we use as well.
Johnny, who I mentioned earlier, all four of you are here today. It's so cool. Johnny said, if you get a resin, I told you you had a resin. I remembered it was resin. If you get a resin 3D printer, you might need some more stuff like a cleaning bucket, 95% alcohol, powder-free. How do you pronounce that?
Nitrate.
Nitro. Okay, yep, that. Gloves, like hand tools to pull off the support beams. What's the difference between 3D, like a resin 3D printer, and what you have, which is...
So a resin printer actually uses a bucket full of resin. Essentially, and the object grows out of the bucket of resin. And then you use alcohol to kind of clean up the model, remove any support structures from it as well. Those are kind of becoming a lot more popular. The build volume, the size of the object that it can build is typically a lot smaller than a traditional 3D printer. But I think for what Johnny is printing, they're pretty small anyways. Yeah. So it's not really a concern.
Stuart said that he has already printed 50 units. I said a couple, so there you go. He said that. Steve Kong says, little tip, because it takes time to design in CAD, blend elements of a product I wanted, blend elements of a product I wanted, so I popped the requirement on Fiverr, and for less than 20 pounds, I got the STL file created.
Yep.
The other thing you can do too, along that line, is if there's a lot of files that already exist for current existing objects. So, for example, and then you can also import an image of something. So for us, like our first version of our litter sifter, we designed it to fit inside of a stock trash can because we wanted to be able to not have to own the mold for a trash can. Very expensive, right? So we designed that, but in order to pop that into 3D CAD, we took a picture of it. And then we imported into the CAD software and just made sure that all the adjustments and everything were right. The other thing is, so there's a whole library of objects that you can pull in. So if you're making a coffee mug, for example, and you're adding a bigger handle or lights or something to it, you can probably find a file of a coffee mug that currently exists, and then you can adjust it from there.
There's a website for it. What's the website, Nick? Thingy or Barcus?
Thingiverse.com is by far the most popular.
Yeah.
Barcus, are you also using that? Or did you use it just to test?
So I used that to print out just a few small upgrades for the printer itself, but then also printing certain things that what I want to sell, just to get a feel of like, how long is this going to take? How much is it going to cost? Like, can I make this stronger? That kind of stuff. So yeah. I mean, Thingiverse is popular, but if you just Google 3D printed STL files, which is the file a slicer needs to slice. Like if you just Google that, there's tons of websites out there.
I'm sharing my screen now. So for those of you who are listening in the podcast, I'll just explain what we're watching, what we're looking at. So this is Stuart who's watching here. I didn't ask him for permission. I hope he doesn't mind. This is an example of the printer that he had. You can see it's not, it's not too big. And this was the first thing that he ever printed, which was from, I'm guessing it's from the website, which I'm never going to remember how it's called. What is it?
Thingiverse. But those benchmarking objects probably actually just came. That didn't come
with it.
Probably.
Yeah. This is not his product. Yeah. This is not his product. Nothing of what I'm going to show is anyone's products, but this is an example of some prototypes like some stuff that you guys, because Nick, I'm going to show what you did as well, had printed just to sort of, this was the first thing some of the first things that each one had a name. One was called Boaty or something. Barcus probably already maybe also printed Boaty. Benchy. Yeah. They all have these weird names. And then I'm now showing, let's see if I can click on it without hearing it. No, I have to mute it. So this is actually Jolita's hand, Nick's wife. It is, oops, hold on. I stopped it. There you go. Here you go. See, you guys can see of some stuff that you 3D printed. Something I wanted to tell some people is something really awesome that you can do. So I'm on Instagram right now is you can go into follow different 3D printing Instagram accounts to get ideas. I have just been blown away by the amount of things that you can 3D print. Like I didn't know that you could 3D print shoes, right? Like, did you all know that? And I'm the only one that didn't know that. I had no idea that you could 3D print shoes. And the more I've looked into this, I'm just going to scroll through while I'm talking. The more I've looked into this, I've noticed like all this, look at this crazy stuff that's 3D printed. It's just insane. That's one thing. And also if you go to Amazon and you type in 3D printed, you can see some things that people are selling as well that are actually 3D printed. And a lot of them are actually like doing really, really well. I wanted to share that with you guys. And something else that I wanted to say, which I've now forgotten, so maybe it'll come to me shortly. Hold on. What was it? Is that while I was doing YouTube, and by the way, I think that YouTube is like the place to learn a lot of this stuff, unless you're Nick and Stuart, right? Stuart's a CAD technician, Nick's an engineer. But I realized that people are making a lot of money from 3D printing stuff and selling it on Etsy and Amazon. For example, I saw there's many like parts for cars, old school cars, that parts don't exist anymore. And people print the parts and sell them online. I also saw a YouTube video of this guy who was 3D printing a part for an Xbox, right? Like for an Xbox remote. And he made like, I can't remember, it was like $40,000, $50,000 in sales on Etsy. I think that 3D printing is just, is something that's only going to grow. And that's why I thought it would be really cool to have this conversation on it. I'll see one more thing that what does this say? Hold on. Is the language for 3D CAD software Auto Lisp? I don't know what that means.
I don't know.
Nick? No?
Never.
Okay, no. Okay, cool. So we're about to wrap it up. Amy, is there anything that you would like to say? Because you also do a lot of coaching and stuff with people.
I would love to share my screen and show you guys some of my early like prototypes and the 3D printer that we built. So if you guys want to see, I can share my screen.
Of course.
Let me see.
Everyone that's listening in the podcast is probably going to go find this on YouTube and just watch this because it's so interesting. Do I need to do something in order for you to share, or do you just click on share?
I think we're good. So I'm going to share, and then you guys should be able to see that. Can you see that?
Yes.
Wow.
So this was
Yep.
one of our first our early concepts, and what we learned is that these edges here, these edges that are meant to pour the nasty stuff out of this scoop, our early design started with hardware mesh in the beginning, and we made it all plastic later. But we learned that these would never work in manufacturing, so we had to fix that. And then you can see this was one of our early 3D prints. So you can see there's a lot of like gluing and kind of things that we had to do together. And this was the printer that we built. And one of the main reasons we used this one from Maker Farm is because of the size of the table. Like this was so huge, we were able to print out. You can see this was what we designed the hardware mesh to snap into. But this is the reason we wanted a bigger printer. So you want to consider the size of your printer as well. So this is what the kind of the top look like. So this is the filament, right? And it coming down through the feeder, and then the extruder there that Nick was talking about. And we just did it in a kitchen, right? In a kitchen. Wow. on the countertop, because I think we eventually moved it. But and then this you can see is the supporting pieces around the piece that we were printing. So this was one of the sides, and then you can see the supporting pieces that also get printed. And I believe this was one of the early CAD designs that we came up with. Oh no, this was later, because see how the sides changed. So just kind of showing you guys.
Which you found to do this because you 3D printed an example, right? A sample of it, and then you used it, and then it gave you understood what changes you needed to make, right, Amy?
Exactly. And then eventually, after talking to a manufacturer and a designer for manufacturing, we learned that it would be too much manual labor to always be injection molding these outer pieces out of plastic and manually inserting this hardware mesh. So we ended up designing the whole thing out of plastic. And so then I had to go back to the drawing board. And what I did is I went to the market, and I'll stop sharing, but I went out on the market, and I looked at litter scoops, things that were already made of plastic. And I was like, okay, what size do these slots need to be to give it the same? Because that hardware mesh worked really, really well. So I wanted something that was just as effective without losing that. But it wasn't going to be scalable with all of that manual labor built into the product. So we needed to make it all of plastic. But you can see we were able to test all of this. Imagine if I had just gone to market with my idea. I mean, this really, really saved us. So just wanted to show you guys that to kind of get an idea there.
This just reminded me of one more thing, and then we'll start to also wrap it up. But it reminded me, there was a product that we're working on last year with a client, and it's a product that already exists on Amazon, but we wanted to make a significant change to it, which more or less the base of it would be the same, but we took another product and put it on the top of it and made it a product, basically 2-in-1. Okay. So what we did, the client was in UK. What we did is we ordered one of the best sellers products from Amazon. I'm going to be very honest. We wanted to do this through a very well-known company. I won't say their name, but they wanted a lot. They wanted like $10K for this process that I think Nick knows who they are, but I won't say it publicly. Very well known for helping inventors. Anyway, they wanted a lot of money for it. We were able to get it done for like less than $1,000. But we ordered the best sellers product from Amazon to him in the UK. He sent it to be 3D scanned. So we had a 3D scan. He sent the 3D scan to a CAD technician, and then and obviously the CAD technician knew exactly what changes we wanted for him to make. But it was much easier for him to do that because he had the 3D scan of the base of the product from somebody else's product, which is not patented, and we made a few changes to it. And then we took his 3D CAD and sent it to a company in the UK for 3D printing. And they 3D printed the first prototype of that product, which later was sent to China. So I just remembered that we did this before I met you, Nick. That we did this about a year ago, and something that's really important. And what I learned from this product, the product was, and this was a great lesson for me, was not as easy to manufacture as we had hoped that it would be. So that's a whole different story for another time. But I could go on about it. I'm sure we all could. Amy, if anyone wants to reach out to you, how and where can they find you?
You can find me at amazingathome.com, and we also have a Facebook group, Amazing at Home. And yeah, I'm around, so would love to hear from you guys. I'm in this nerd space. I love to develop products. I love to see people bring their ideas to life. Like, those are the things that sell. Those are the things that connect with customers. Like, it's just really cool. So, if you have an idea and you want to make it happen, it's just been awesome being here with you guys today, because I think we've given everyone, like, you can't leave this discussion today and have an excuse not to at least try out your ideas, right? So thanks so much for having me.
I feel if I had a twin in the industry, it would be you, Amy, because you and I are I'm not as great as you are, and I'm not an inventor, but I feel though that if I had a twin in the industry, it would be, because you and I think a lot, very, like, we don't do product research like other people, and we're like committee things. So, thank you for being here. Barcus, we're going to do a catch up in about a month, and I'd love to hear where you are in your 3D printing. By the way, you're really far away, so you're all blurry, unless it's my eyes. Unless it's my eyes, because I haven't got my glasses on. We're going to catch up in like a month. I'd love to see where your 3D printing career is going to be shortly. How long, just so we put it out there to the world so that it happens, how long do you think it's going to take for you to send your first batch of 3D printed products to Amazon?
I'm hoping in just a couple of weeks. So I've been trying to, I'm not this good about documenting a process and putting it online. So I'm trying, but I did a stress test. So I ran my printer, four parts that I need, and I ran it for 24 hours. I just wanted to see, and I realized some mistakes that I had made. So I'm going through this process, like how long will it take to can I speed this process up? Because that will tell me how much I can sell. So I'm hoping in the next couple of weeks. I've already got 2 products that I've got kind of everything really tweaked as far as structure, integrity, that kind of stuff. So I'll just throw them in some boxes and ship it, and I'll be 100 air before you know it.
So let's just say we'll have you back in the end of March and see how it went. End of March is plenty of time. Maybe Nick, I'm sure, will agree to come back. Maybe by then Joel, Stuart, and Johnny will also agree to come on, and we could all talk about how this whole thing has also gone for you guys. Barcus, if anyone wants to reach out to you and talk to you about some awesome stuff, where they can get a hold of you.
Facebook or Instagram, just shoot me a message. That's the easiest way. If I'm just Barcus Patty. If you can't find me, then I don't want to talk to you. I don't know what to say, because it's a pretty unique name. So I'm out there though.
Cool. Thank you, Barcus. You can also hear Barcus once in a while on, and Amy as well, and myself on Clubhouse, which is actually where I at least started actually communicating with people. So Barcus was also on follow Barcus and Amy and myself and Nick, who's also on Clubhouse. Nick, if anyone, because I'm sure you're going to get a lot of messages now, if anyone wants to reach out to you, you need to start charging for this now, Nick. Consultations on 3D printing. Nick, if someone wants to reach out to you, where can they find you?
Like Sharon said, I'm on Clubhouse. My name on Clubhouse is Carbon Kickstand, or you can reach out to me on Facebook. It's actually Nicholas Citrini, Citrini on Facebook. Be happy to help.
Awesome. If you can't find Nick, you can always send me a message and I'll hook you up. And if anyone wants to find me, you can also send me a message on Facebook or Instagram or Clubhouse. And that's it. Thank you guys so much for being here. I think that a lot of people got a lot of value from here. We appreciate you all. We should probably do a part 2 all together as well sometime soon. We'll see you all next time. Thanks, guys.
Bye.
Bye.